Jai Gurudev children. So today again we are going to start first about the linkage. Now in last class I have explained what is linkage. So I think at least you all have some idea about the linkage. So linkage means the genes present in a particular chromosome, and if they whole sets of gene present in a particular chromosome, if it is transferred to the offspring, then it is said that in it the complete linkage takes place. But if partially if it is transferred, then it is said to be incomplete linkage, and which is very common phenomenon. But along with it, we have also studied that complete linkage, it doesn't take place because of the meiosis cell division which occurs in all sexually reproducing organism. So while explaining, I have also mentioned that distance is related with the percentage of linkage. That means more the distance between two genes, more chances for recombination, and in that case the crossing over will take place, and in that the whole chromosome, or not the chromosome, means the whole set of gene will not be transferred to the offspring. So distance, more the distance, more chance for recombination, less the distance, more chance for linkage. So that much was explained in the last class. Now, along with it, now while studying the linkage by Morgan, one of his student, Alfred, he had explained another concept which is known as the genetic map. Now, genetic map, which just simply in short it is explained. So in detail we will also not go. Just you have to know what is genetic map, or sometimes it is also known as the chromosomal map. So it means the graphic representation of gene in the chromosome. In chromosome means all the genes which are present in a particular chromosome, how they are arranged, which gene is located in which particular locus or position. All these things we can study through the genetic map. So it is one way of finding the relationship, or to find out how one gene is linked with the other, or one can get the idea where the possibilities of linkage will be more, or where the possibility of recombination will be more. So this much only you have to know about the genetic map, and this concept was given by Alfred. Now, while explaining this, you just say here, just to explain one idea to give about the genetic map, here I have taken one example. Now, example means what? In a particular chromosome, there three types of genes are present, and it is said that between A and B, the distance is 15 units apart. Between A and C, the distance or the gap is 5 units apart. Now, if you are asked to plot these three genes in a particular chromosome, the possibilities are two. Means one, if you all get the hint how far the genes are located in a particular chromosome, at least you can have the idea where to plot. Now for this one, two possibilities are there. Now here just first I have shown you, you just see this the straight line. So first, since A to B it is given, so let us assume from here to here the distance is 15 units. Then the next is given that between A to C is 5 units. But the position is not given. So here two possibilities are there. That C position, it may be located in between the A and B, or it may be located in front of A. So two possible answers are there for this particular question. So here I have shown, so this C, it may be located somewhere in between the A and B, or it may be located outside A, that is C. So in this way, now here two possibilities are there. So by chance in exam, if you get like this type of question, so both the answer will be correct. But here just I have given you this example only to show that through genetic map or getting some hints how the genes are located, one can easily find out which genes are located in the beginning, which is in the middle, and which at the other end. So this is one way of representing the gene in a particular chromosome. Okay, so usually like this type of question till now it is not asked, but possibilities are there since they have explained about the genetic map. So you have to know how to plot if you are given this type of question. Now maybe you haven't practiced this type of question, but in maths when in lower class you all have studied about the line segment, and there I think similar type of sum using centimeter meter you all have done. So same procedure you have to follow if you get like this type of question. Now, so this much about the genetic maps which we have studied along with the linkage. So three things we have studied from the linkage part. One is the what is linkage. Next one, why complete linkage is not possible always, or why it is rare, because of the recombinations or because of the crossing over which is very common in the sexually reproducing organism. Then the third thing we have studied is about the genetic map. That means the graphical representations of gene within a particular chromosome, how they are located, and by knowing the genetic means through genetic map or by knowing the position of various genes in a particular chromosome, one can find out where the percentage of linkage will be maximum and where the percentage of recombination will be maximum. So this much about the linkage. Now next you have in your book another concept about the sex determination. So before explaining that, just two things you all have to know that chromosome, now you have the idea. So whatever the chromosome in a particular individual they have, it is divided into two types. One set it is known as autosome. They are related with the somatic characters. And usually the autosomes means here all the chromosomes are of same size and shape. But the other one, that is the sex chromosome, which usually of different shape. And that in case of human, now if we take the example of human, we are having 23 pairs, out of which 22 pairs are the autosome chromosome and only one pair is the sex chromosome, which in case of female it is XX, which is known as homogamete, similar, and in case of male it is XY, that is heterogamete. That means two different types of gametes are there. Now, based on the type of sex chromosome, in your book, there 4 different types of sex determinations are explained. So now we are going to discuss about those things. So the first one, in your book, they're just simple, very simple, but very often question is asked from this part. So here, means the first one, it is given the sex determination XXXY chromosome. Means here, this means whatever the combinations are shown here, these are all the sex chromosome present in the male and female in different organism. Now the first one, that is XX, this is for the female, and XY, it is for the male. Now the example for this type is mostly the human, and some other examples are there. You can go through in your books, the examples are given. So sometimes only the examples you are asked to write by where they give the sex determination. So you have to learn all the examples. So in this type of determination, it is said that the female, they are having both the same types of gametes. So that is one type of gamete only it will form, that is X, and XY, two different types of gamete, that is X and Y. So when the crossing will take place, the chances are there for developing both the male and female, that is 50%, 50%. So if an individual is having XX combination, it will give rise to a female, and if it is having XY, it will give rise to a male. So this is one type of sex determination. And here one more thing you have to remember, that when they are having both XX, it is said to be homogamete. And when they are having two different types, it is said to be heterogamete. Now another example is given, that is XX and X0. Now 0 or X0. Now here one thing children, you all should know, this O or 0, it indicates, that means in that individual, one chromosome is absent. So when it is absent, it is denoted by 0. And this particular character, it is present in male. And the other one, it is in case of female. Means both are homo and this one is absent. So when the crossing are done, after crossing, if two X meet, it will always give rise to a female. And if means X meet and where one of them is absent, which is denoted by O, then it will always give rise to a male. So this is another type of sex determination. It is means another type of sex determination. It is found in grasshopper, in some insect it is found. Then you have the third type, it's little bit different. Here the female is the heterogamete and male is the homogamete. So, and it is denoted by different alphabet, that is ZW and ZZ. And in case of female, here two types of gametes are there, that is Z and W. And in case of male, it is both are Z. So only one I have shown. So when they crossing will take place among them, then if two Z meet, it will always give rise to a male. And if two different gametes meet, that is ZW, it will give rise to a female. So sometimes the question is asked, how the sex determination takes place in bird, or sometimes it is asked, why in case of bird the female are heterogamete and in case of human the male are heterogamete. So in that case you have to know what do you mean by homogamete and the heterogamete. Then another type is there which in your book it is not given, but if you go through some reference book you will come across this one. Now this one also it is of Z0 and ZZ. So here also means in some insect, that means some butterfly. Now one thing, butterfly and moth, many types are there. So out of them, some of the group, they are having this combination. So here 0 means what? In it one chromosome is missing. So it is Z0 and that is present in case of female. And in case of mammal, in case of male, not I made mistake, mammal, it should be in case of male, it is ZZ. So here also, that means what? In this type, W is missing. So when the combination means when the crossing are done and the gametes, when both Z meet, it will always give rise to a male. And if only one Z is present, it will give rise to a female. So in this way, the sex determination, it is found in different groups of organism, which may be human, which may be fruit fly, which may be birds. So sometimes, very often for 3 months, questions are asked based on the sex determination. So when you are asked, you have to show the crossing and you have to explain it, whatever the question, if they means whatever it is asked, and accordingly you have to represent. Now, beside this, another explanation is given in your book. Now there it is some exceptional case which is seen in some of it. One such example is in case of honeybee. Now here, one thing children you all should know. Now you all know little bit idea you all have about the reproduction process. Now, and one thing you all know, reproduction, it is of two types, asexual and sexual reproduction. And in asexual reproduction, a single individual is responsible to multiply. But in sexually reproducing organism, means two different individuals meet and ultimately give rise to a new individual. But there is some other terms too there. One such term is the parthenogenesis. Now, parthenogenesis means the fertilization without means in it that fertilization process, it doesn't take place. Without fertilization, they give rise to a new organism. So in animals, if it gives rise to a new organism without fertilization, it is said to be the parthenogenesis process. So this process is common in case of honeybee. Now you just see for that one, it is, now you just see here it is given this one, and they are having the chromosome number 32. So in case of female, it is 32, and in case of male, it is 16. That means n numbers of haploid. Now the female, they always undergo meiosis cell division, and it means meiosis means what? Reduction division takes place, and that means 16-16. Two gametes each having 16-16. So, but the male which is having 16, so in it the mitosis takes place and give rise to same number of chromosome, that is the 16. That is also male. Now this male 16, some of them mate with 16 means mate with another gametes from the female, and there the fertilization takes place. And if fertilization takes place between the female and the male gametes, it gives rise to only female. That is 32 chromosome they are going to have. Now, if without fertilization, if they give rise to a new organism, that will be male, that is drone, and in that case, in it, the fertilization process is absent. And in it, the process, it is said to be parthenogenesis. And always through parthenogenesis, the organism which are formed, always it will be a male. So that's why this type of sex determination or this type of process, it is said to be haplodiploid sex determination process. Means in some case it is haploid and in some case it is diploid. So that's why both the terms are given. So this is one exception in case of honeybee. So in honeybee, both the fertilization takes place and if through fertilization it gives rise to a female, it will always give rise to a female, and without fertilization, it will give rise to a male. And in that case, it is said to be parthenogenesis. So this much you have to know about the sex determination. So sometimes the question you may get related with the honeybee, why it is called haplodiploid term is used to explain the honeybee sex determination. So this much you have to know. Now, beside this, now the next topic in your book, it is explained is about the mutation. Now children, already I have explained what is mutation. So simply, in short, just I'm going to explain. Mutation means sudden change in the genetic setup. Now that change means if it takes place in a particular gene, it is said to be point mutation, or sometimes even another term is used that is known as frame shift mutation, which earlier also in the evolution chapter I have explained. Now here in this chapter, they have explained again this using the example of one disease, that is the sickle cell anemia. Now for this one, again I am repeating. Now you just see, now you have the idea of what is mutation. So mutation means, if you imagine THEREDHATD, these are different genes present in a particular chromosome. So if some changes occur in any of these genes, it will bring change to the whole setup. Whole setup means their phenotypic character will change. And that only it is said to be the mutation. And the agent responsible for bringing changes, they are said to be mutagen. So those things I have given you in the form of PDF, you can go through it. Now here you just see, now instead of just if I read the red hat and just D I have written. Now from here, if from RED, now at least when it is given the red hat, at least you have idea what we are talking about. Now suddenly if this D is deleted or is removed for some reaction, then what will happen? Now D will be removed, and here the shifting of the gene will take place from the other side. That means H will be shifted here. Now you just see, now it is the REHATD. So here what happened? The shifting of the letter has taken place, and it has no meaning, or it may give rise to some new type. And this is said to be the mutation. And since the shifting has taken place, it is termed as frame shift mutation. Now, while explaining this earlier also I have explained, I was talking about the genetic code. Means whatever the amino acids we are having, each of these amino acids, they are represented by three letters. Now, out of those 3 letters, if one is removed means what? Due to some chemical reaction or some new letter, if it is added, it will not give rise to the original amino acids. And in that way, it will bring change in the whole phenotypic character. So that's why it is said to be frame shift mutation. So here just simply I have explained. Now to explain this, in your book, there they have explained about the sickle cell anemia. Now sickle cell anemia means what? There what happened? The shape of the red blood cell, it changes due to the change in the amino acid in the 6th position of the beta hemoglobin chain of the human. Means like this here in your book also, if you see, like this different amino acids are there. Each of them, they are represented by three letter. Now in the 6th position, you just see they have GAG, which represent glutamic acid. Now during what happened due to mutation, what happened? This A letter, it is replaced by U. So once when this A is replaced by U, instead of giving rise GLU, it gives rise to valine. So as a result, what happened? Here, one new type of amino acids form, and due to the formation of these new amino acid, the shape of the RBC cell changes. And now it is impossible for them to trap maximum amount of oxygen. And in such case, that individual suffer from sickle cell anemia. And here it is said this one is an example of point mutation. Why? Because this A letter, GAG, this A letter or one letter has been replaced by another letter, that is U. And due to that replacement of it, the change of the amino acid has taken place. From glutamic, it has changed to valine. And due to which that individual suffer from sickle cell anemia. So this is an example of the point mutation. So this much for today. You go through it. Next class, again, we will discuss about it. So this much. Thank you.